So in this video, we're going to go through section 5.3, which is about kites and trapezoids. So first, you could also copy these conjectures, and once we fill them into your notebook if you want. So first we'll go through properties of kites. It's a GeoGebra file. So here is a kite that I've constructed. Remember, a kite is a quadrilateral where these two sides are the same and these two sides are the same, yet they're different than the first two. So I can drag this around and kind of change the size of it, but it should always remain a kite. And I've drawn in the diagonals. So we're just first off just going to measure. This first conjecture says the blank angles of a kite are blank. So we're going to just measure all the angles just to see what's going on. So angle FCE and angle FAE. Okay, these are called the vertex angles because they're the ones that are in between the two congruent sides. So I'm going to write that here. These are the vertex angles. Okay, so those are not the same. And that should be fairly obvious in this diagram. But if we measure the non-vertex angles, so these are called non-vertex angles. So angle F and angle E, the non-vertex angles. If we measure those, what do we notice? Let's see, measure angle CFA and CEA. And we should notice that those are the same. Okay, so non-vertex angles are the same. Is that always true? I can drag this around and see the vertex angles are different. The non-vertex angles are always the same. So I'm going to go back to this doc and we can fill this in and say non-vertex angles of a kite are congruent. That's the first conjecture. The diagonals of a kite are blank. So this one should be obvious to see. The diagonals are these two lines or segments. And it's getting at what is the angle created here? It looks like a right angle. We could measure it to be sure that it's always going to stay that way, and it will. And that hopefully that is intuitive to you, that these, no matter how I drag it around, they are always going to be perpendicular. So we can fill that in. Diagonals of a kite are perpendicular. The diagonal connecting vertex angles of a kite is the blank of the other diagonal. So that's getting at the fact that, notice this segment FG looks to be about the same as GE. So we could measure FG and GE. Those are always going to be the same. So we're saying that this diagonal bisects the other diagonal. It cuts it in half. But that's not true about the first diagonal. Those sides CG is not the same as CA. So the diagonal connecting vertex angles of a kite is the bisector of the other diagonal. Conjecture number 4, the blank angles of a kite are blank by a blank. So the first conjecture is about the non-vertex angles. This one's going to be about the vertex angles. So what's true about those? Well, if we look at these two angles, remember this triangle right here is isosceles. So this vertex angle of an isosceles triangle is always bisected by this diagonal. So these two angles should be the same, and these two angles should be the same. But that's not necessarily true about the non-vertex angles. See, one angle is slightly smaller than the other one, and we can see that maybe there's a case where they're the same, but then this isn't a kite anymore. It would be a rhombus. And so that's a topic for a different day. But as long as it's a kite, the non-vertex angles are not bisected by that diagonal, but the vertex angles are bisected by this diagonal, which means if I measure angle FCG and angle ECG, those are the same no matter what. Okay, so we go back to our conjectures. The vertex angles of a kite are bisected by a diagonal. Okay, so that's it for kites.